On July 29th of 2019, it was announced that hackers were able to gain access to about 140,000 social security numbers, 80,000 bank accounts numbers, and approximately 1 million social insurance numbers from US and Canadian customers of Capital One Financial Corporation. Just a week earlier, the attacker was able to retrieve a set of AWS access keys by exploiting a server-side request forgery, also known as SSRF vulnerability. Due to this, they were able to use those keys to access AWS S3 buckets that provided access to all the data I just mentioned. But what is a SSRF vulnerability, and how can attackers exploit it to perform attacks like that? SSRF is currently ranked last on the OWASP Top 10 Web Security Vulnerability list and was added to the ranking via the Top 10 Community Survey. This video will explain this vulnerability and present a deeper look into what SSRF is, what different types of SSRF attacks there are, how an SSRF attack is performed, and what countermeasures can be initiated to prevent such a vulnerability to occur in a web application. What is SSRF? Server-side request forgery is a web vulnerability that can be exploited by hackers to redirect the request the server-side makes to a different unintended location. By this, the server-side application can be tricked to allow the attacker to access the server or other resources. Typically, the malicious user adds or edits a HTTP request to the resource they want to target. In case of a successful SSRF attack, the results can vary from access to unauthorized areas or data to the revelation of authentication tokens or credentials. Since URL fetching gets more and more common in modern web applications, as well as due to the rise of the usage of cloud services, the possibility of a SSRF vulnerability occurring is also increasing. Types of attacks. SSRF attacks exploit the implemented trust relationship a web application has with different parts of an organization's infrastructure, like the server of the application itself or other parts of the organization's backend systems. Because of this, the way a SSRF attack can be performed can be categorized into two different types: SSRF attacks against a server, as well as SSRF attacks against other backend systems. In case of an attack against the server of the web application, the attacker uses a URL HTTP request used by the client application, usually in form of a web application, that is sent to the server and either modifies or replaces it with a different URL. Usually, the new URL contains a host name that posts to the so-called loopback adapter, like 127.0.0.1 or localhost. The loopback adapter is a network interface that is used to send network traffic between different applications on the same computer. Other than that, it's not able to route the traffic to other devices in the network. By using the loopback adapter as the host name, the malicious HTTP request now points to the local file system of the server. As an example, let's say there's an online shopping website, and one part of the website there's a function where the user is able to find out if the item they're looking for is currently in stock. For this, the application has to perform a REST API query to the backend. This works by sending the URL to the API endpoint via HTTP request from the front end that can look like something like this. This results in the server to make a request to the URL that was specified in the stock API line. In case of an SSRF against the server, the attacker would then replace the URL that asks for the stock value of the product with a URL that requests something locally from the server itself. For example, like this. In this case, the server will perform a request to the contents of the /admin URL and return the results to the user that sent the request. By performing this kind of attack, the attacker is able to bypass the access controls that prevent an unauthorized user to simply browse to the /admin page. This works because to the server, it seems like the origin of the request is a trusted location, since without the modification, it's part of the functionality of an online shop. The other type of SSRF attacks occurs if the server of the application in which the SSRF vulnerability occurs has the ability to communicate with other systems in the backend that normally users aren't able to directly reach. In that case, it is still necessary that the server of the application is able to communicate with the other machine that is located in the same internal network as the server. In this case, the attacker can get the ability to modify the URL in the API request to this other machine. To do this, instead of putting the loopback adapter like localhost as the host, the attacker uses an IP address like 129.186.0.68, which is typically used as an external gateway to the internal network the server is located at. To further use the previous example, let's say there is an administrative function at the backend located at 192.168.0.68/admin. Now the attacker might replace the stock value request URL with a payload like this. This way, the attacker is able to bypass any authentications that might be implemented on the application, since backend systems often don't have a very well implemented security, as they usually should be protected by the network topology. Often, sensitive functionality like admin interfaces can be found on backend systems on the internal network, and anyone who finds a way to interact with the systems is able to access them with any further authentication. Regarding the attack example from the introduction, similar to this, attackers also might be able to access cloud API endpoints by using the right URL. For example, by using the IP 169.254.169.254 as the host in an SSRF attack, the request will be sent to the AWS EC2 metadata endpoint. For an SSRF attack, it is also important to distinguish between blind, partial blind, and non-blind SSRF attacks. In case of a blind SSRF attack, the attacker is not able to see any part of the response to their malicious request. On the other hand, a non-blind SSRF attack results in the response to be viewed completely to the attacker. Between those two extremes lays the partial blind SSRF attack, in which the attacker is able to view a part of the response, for example in form of a status code or a specific part of the response. An example for a blind SSRF attack could be requesting a file with a rather big size from the server that is too large for the server to process, causing it to crash. An attack like that would result in a denial of service and is considered blind, as the attacker is not attempting to access any data. How to find an SSRF vulnerability? There are different ways to find this type of vulnerability in a web application, and many of them are rather easy to find. The best way is to look for any places where request parameters are located that contain full or partial URLs. Some examples are a full URL that is found in an address bar parameter or in a hidden field in a form, or a partial URL, for example, just the name of the host or just part of the URL. Another place to find an SSRF vulnerability would be in applications that use data formats like XML to transmit structured data from the client to the server. In this case, a XXE vulnerability can occur, which makes a SSRF possible. There will be more details on that in an upcoming video about XXE that I'm currently working on. So this demo should show you on a hands-on basis how a simple SSRF attack against a server can look like. It's based on the example mentioned earlier, and for this we're using the Portswigger Web Security Academy lab. Those labs are deliberately insecure websites provided to practice web security attacks on a legal basis. If you want to check it out yourself, I will put a link in the video description that takes you to the SSRF labs on the page. Additional to that, we'll be using the software Burpsuit to intercept and modify a request. You can find more about the Burpsuit also via the link I put in the description. So let's head into it. So we have this online storefront, and for each product they sell, just let's click onto here the lazy dog. They have a option where you can choose a certain city store and check if the product is still in stock in that store. Now, what we're going to do is now choose any store. I'm going to go by London. And we're going to click check stock on that store. And in the next step, we're going to open WebSuite and find the post request here. That was made when we hit the check stock button. On closer inspection, we can see that the request is sent to a certain URL. You can see it down here, stock API, and there we have the URL where the request was sent to. And what we're going to do next is send the request here to the verb repeater. And we can now head over to the repeater tab, and here we have the request we just saw. And what we're going to do next is we can replace the original stock API URL with the URL localhost/admin to see if we can access any admin functionality by performing an SSRF attack. So we're going to click here send. And what we can see here is that in the response, we see a few HTML elements, and down here we can also see some form fields allowing the user to delete some users' accounts, for example, by using this URL. So in the last step, what we're going to do next is send the request again, but this time we're also going to add this URL instead of just admin. And what we can see here is on the admin panel, we can delete the user with the username Wiener. And now we're just going to resend the request. And it worked. We were able to delete the user with the username Wiener by using a simple SSRF attack. Countermeasures. The risk of a successful SSRF are high. By exploiting a vulnerability like this, attackers might be able to manipulate the servers of web applications to grant them unauthorized access to informations and functions. Resulting in this, an SSRF attack can lead to the exposure of sensitive data, denial of service attacks, or attacks like remote code execution. But as always, there are a few countermeasures that can be implemented to protect a server infrastructure from containing server-side request forgery vulnerabilities. First of all, and this goes for preventing almost any web vulnerability, is validating user input. It's always best practice to confirm any type of user input is indeed input that the application's backend should process. This goes hand in hand with so-called allow list checks that validate if the IP address and DNS names used in a request actually require access to the infrastructure's assets. Next, it's highly recommended to always implement the principle of least privilege when choosing the necessary rights to access a resource, and users only get the least minimum permissions to use the application without any problems. Also, access control checks should always be implemented on the back end of a web application, and it's important that all internal resources should be protected as well. Oftentimes, it's assumed they don't need any additional protection as they're not directly accessible for the users. But remembering attacks like SSRF, it's still possible. The last and probably most important countermeasures against multiple web application attacks is by installing a so-called web application firewall, or short WAF, that can work as a protection against automated as well as more advanced attacks. I hope by now, via this video, you should have a good overview of server-side request forgery attacks. Attacks like this can lead to multiple possible types of outcome, like the exposure of sensitive data or the unauthorized performance of actions on the backend infrastructure of web applications. Especially with the rise of the usage of cloud services and URL fetching functions in web applications, the possibility of a SSRF vulnerability occurring is also rising. It's important to always implement countermeasures like input validation, allow list checks, or web application firewalls when building a web application to mitigate the risk of an SSRF vulnerability to occur. You will find all the links to the resources and websites I mentioned in this video in the description. And if you're interested in learning more about web security, feel free to check out my other videos. Until then, I wish you a delightful day and see you soon in the next video. Goodbye.